Howdy, this is Team Thrust Stand. Our members are Christopher Kapfer, Eric Garcia, Miguel Rico, Jacob Roach, and Kaysen Smith. We will showcase our senior capstone project on a Sub-MicroNewton thrust stand for space propulsion testing. Our sponsor is Dr. Christopher Limbach, who is an aerospace engineering assistant professor at Texas A&M. Dr. Limbach's research consists of laser diagnostics and plasma devices, as well as the application of plasmas for aerodynamic control, propulsion, and combustion. Dr. Limbach has tasked the team with a design opportunity to help further his research on plasma propulsion. Our team has been tasked to design a sub-micronewton thrust stand capable of measuring static and impulse forces of thrusters for microspacecraft in the micronewton range. The requirements for this design are as follows. It must measure static forces less than 1 micronewton as well as impulse forces less than 1 micronewton second. It must be immune to magnetic fields of up to 0.5 teslas. It must provide provisions for electrical and gas feeds, as well as be immune to up to 100 watts of heat during testing. And lastly, it must successfully mate to a 14-inch steel flange for vacuum testing. For this project, the team chose the torsional balance design for the sub-micronewton thrust stand. This design was recommended to the team by Dr. Limbach due to its proven concept from other manufactured and tested thrust stands. This design provides the highest resolution for measurements and provides a low cost to fabricate. The team used previous designs to base their concept but had to make modifications due to the vacuum compatibility requirements. The team's design of the torsional balanced thrust stand was constructed with a series of metals that were resistant to magnetic fields, rated to prevent outgassing in a vacuum environment, and were resistant to high temperatures. The team constructed the torsional balanced thrust stand shown here placed within the vacuum chamber while attached to one of the stainless steel flanges. To show the geometric constraints of the thrust stand, the flange is approximately 14 inches in diameter, and the highlighted edge of the counterweight is 1.5 inches tall. The team's fully fabricated thrust stand attached to the flange is shown on the left, and the thrust arm with an applied thermal coating is shown on the right. In order to measure the displacement of the thrust arm, the team chose to use interferometry. Interferometry is a precise laser measurement method that uses a system of lenses and mirrors to measure displacements. The images pictured here show the team's interferometry setup that allowed the team to measure the minuscule changes in distance of the thrust arm during calibration and testing. Some of the challenges the team encountered included the need to dissipate heat to prevent overheating and warping of the thrust stand, the need to overcome a volumetric conflict with the use of counterweights to balance the thrust stand during testing, and address programming issues to collect accurate data with interferometry. The team solved these challenges with several solutions. First, the thermal coating was applied to enhance the heat transfer properties and prevent excessive heat buildup on the thrust stand components. The team also implemented the use of tungsten cubes to balance the thrust stand during calibration and testing due to tungsten's high density. And finally, the team spent considerable time to debug the LabVIEW VI during calibration and testing processes. In summary, the team fulfilled the design requirements given by Dr. Limbach and developed a fully fabricated sub-micronewton thrust stand. In addition, the team also provided an interferometry setup using equipment for ideal data acquisition. For future work, there are several things to address to improve the team's final design, which includes modifying the program and hardware to collect real-time thrust force calculations, adapt the interferometry setup for testing the microthruster inside the vacuum chamber, and finally modifying the thrust stand for two-axis positioning.